Good afternoon, everybody, and welcome back to the post-lunch session. This is a dream session for obvious reasons, and I would request that you keep your ears open. We have galaxy of experts who have expertise in wide variety of subjects. I'm sure that they'll ignite your passion of safety and douse the flames of ignorance or unsafe practices that you have, if any. To kickstart the session, we have Mr. Rajesh Vadhava, a mechanical engineer from Bharat Petroleum. He has 35 years of experience in inspection and maintenance of mounted pressure vessels, and he's been a member of the OISD task force team for reviewing various standards, and he's also a member of the safety audit team. To discuss in details, I would request Mr. Rajesh Vadhava to continue the proceedings. Mr. Vadhava, please.
First of all, I must thank PESO for giving me an opportunity to talk to this August gathering. My topic is maintenance and inspection of LPG mounted bullet. I'll be talking about my personal experience which we have gained over a period. In fact, BPCL was the first company who has undergone the M&I activity of mounted bullets in the country, which is attached with the refineries. See, basically LPG, I'll start with this, that mounted bullet, what is the necessity of the mounted bullet? So to start with, LPG is nothing but a mixture of propane and butane, which is a colorless but heavier than the air, which makes it more susceptible for fire and explosion hazards. The conventional method of storage of LPG, normally two methods are there, either in a pressurized manner or we can do it in a cryogenic storage options. But both the options are being used depending upon the techno-economic feasibility. See, storage option as an approximate guide, the fully pressurized storage tanks is normally used for a capacity up to 3,500 meter cube approximately, and while the cryogenic condition we use it up to 1 lakh meter cube. And in the cryogenic condition, the tanks are basically atmospheric storage tank and not a pressure vessel, and it has to be a double containment vessels. It can be a double containment, can be a double concrete wall, or it can be a double steel wall, or it can be a underground caverns also. See, major hazards which is attached with the LPG storage is mainly a BLEVE. In 1984, when in Mexico the BLEVE incident has occurred, at that time a need was felt that we should have we have to invent an option for storage of LPG by which we can avoid the BLEVE effect. So then the mounted bullet has come up. The BLEVE is nothing but is a boiling liquid evaporating vapor explosion, which is nothing but a physical explosion. Then the force is so high when BLEVE occurs. In Mexico incident, it has gone up to, the effect was felt up to 1.2 kilometer from the incident place. Since LPG, when it evaporates, it expands 250 times. So just you can imagine what type of pressure waves it will generate when the vessel explodes and fireball is generated and it moves off. So typically, depending upon the type of storage, we may have only LPG. We can have a propane as well as butane. So propane, basically depending upon the RVP, normally the vapor pressure is higher. So design pressure normally we keep it at 18 kg. In butane it is lower, so we keep it at a 7 kg, 7 bars. So pressure vessel in an atmosphere, in a pressurized condition, what is the limitation? The thickness of the vessel, normally we limit it up to the 50 millimeter. So beyond that, if you go for the higher thick vessel, then it has its own issues. So it is the capacity which is limiting is based on the thickness, total thickness what we are looking for it. We are not going beyond 50 mm. If it goes for more 50 mm, then definitely more and more stringent requirement comes into the picture. Mounted bullet is nothing but a storage vessel which is sited above ground and completely covered with a mound of a earth or a similar inert material except for nozzles and manhole which comes out on the top. The mounted bullet of a storage of LPG has proved to be safer as compared to the other above ground vessels. This is eliminates the possibility of any engulfment and radiation of fire in close proximity. Mounted bullet have a sand cover around that which can take the impact of external projectiles or flying objects. Area of land required to locate mounted bullet is minimum. Mounted storage is designed to consider maximum working temperature as 55 degrees centigrade. So basic advantage of mounted bullet is nothing but no blavy, no damage due to heat radiation due to the nearby fire, no damage due to the pressure wave due to from the nearby explosion, no damage due to the sabotage because it is covered, no additional space requirement, no extensive water deluge system since it is covered in the mount. But there is one limitation is there because we cannot have access to the external surface. In case of any soil side corrosion is happening, it is difficult to access that. This is just a picture. So, but in mounted bullet also, though it is covered in the mount, there are certain interdistances which we are supposed to maintain in the mounted bullet. Separation distance are intended to minimize both potential for small leak, ignition and exposure risk presented to adjacent vessel, equipment or installation in case of ignition occurs. Separation distance are not intended to provide protection from major incident. Risk analysis and dispersion modeling are recommended tool to limit the exposure risk to the adjacent facilities. These are just a table which gives the normally, it depends upon the capacity of the mounted bullet, the separation distances are decided. See, another major aspect is that wherever mounted bullets are there, we have to have an access for the bullets from two sides to fight the fire, and a fire hydrant has to be located in such a way so that it is in a safe location. Locate the LPG storage far away from the main units in the downwind directions. And these are the applicable standards whenever we are deciding about the mounted bullets storage of LPG. These are some safety features. I will come to my topic now. Now, basically, the maintenance, there are challenges when mounted bullets are to be maintained as well as inspected. So, inspection is a major criteria whenever to ensure the integrity of any vessel. See, it started with a reactive maintenance, goes to the preventive maintenance, then predictive maintenance, and then it goes to the proactive maintenance, and finally we lead to the total productive maintenance. The question is reactive maintenance. When any equipment fails, at that time if you fix it up, then it becomes a reactive maintenance. But in mounted bullet, which is protected with the help of a cathodic protection, it needs to be monitored on a periodical basis. And when we are monitoring it periodically, we come to know what are the where are the issues are coming up, and those has to be addressed when is the next M&I we are taking up. See, reliability is very important as far as safety is concerned. Any vessel, any asset which we are operating, it has to be reliable. And to ensure the reliability, we have to first asset integrity has to be ensured, its availability has to be ensured, as well as the minimum repairs we have to carry out. So to carry out the minimum repair, what is more important is we have to assess the total what are the damages are there which are likely to happen and what damages has already taken place, so that we can take a corrective action in time. If it is late, then definitely my cost of repair will go up. Now, what are the issues related with M&I? See, normally these bullets are very long vessels underground. So, major issues are ventilation, illumination, easy access and space to move around. Because inside, since they are long vessel, internally there are a lot of stiffening rings are there, a lot of restrictions are there. It doesn't allow a free movement. So, these are the issues which are there, which has to be addressed whenever we are doing M&I of any mounted bullets. See, for ventilation, what is our experience is we provided a reaction fan on one end. There are one fan, and second thing, in the other outlet nozzle we have provided a eductor. So with the help of eductor, the reaction fan was giving the air inside, and from the eductor side it was taking it out. So inside the vessel we were able to provide a proper ventilation. Normally 5 air change per hour is required to have a better feeling for better working inside the vessel. Similarly for illumination also, because it's a long vessel, illumination is very important. Otherwise, and because of lot of restrictions are there inside, lot of constraints are there, if it is not illuminated properly, then definitely there are chances of some accident might take place or some slippage might take place to the people who are working inside. So illumination is also and we have to plan the illumination. Every 3 meter distance we have to have some light source. Then for easy movement inside the vessel, we require some methodology by which we can make a easy access. What we did is, we provided a temporary rail inside the vessel. Temporary rail was erected, and on the top of it, this is a rail arrangement we made it, because we cannot take anything inside. It has to be in the pieces which will take it inside from the manhole, and then it is erected inside. Then a temporary arrangement was made to make an access all around. See, another issue is the material of construction. For refinery, actually in refinery cases, where normally we use a low tensile strength material. The basic reason for this is because in refinery, the LPG we are receiving after the treatment, LPG treater, and LPG treater we are using caustic as a treatment for treatment. And there are always a possibility that sometimes the caustic may carry over, it may come to your storage mounted bullet. And because of the caustic being a poisonous liquid, it may damage the steel. So there we always try to provide a lower strength steel. While in a marketing installation where there is no possibility of any caustic carryover is there we can go ahead with the higher strength steel, which can reduce the thickness. Third thing, the cathodic protection system which is provided, mainly the PSP readings, these are the frequency which has been given as per the OSD guidelines. In OSD 150 gives the guidelines. Then second thing is, one more important point is, since it is a large vessel and huge weight is there, the settlement is very important. This has to be measured periodically. Hydro testing of the vessel as per the OSD requirement is once in a 10 years, and internal inspection is once in a 5 years. Expected damage mechanism is nothing but, in case of refinery mounted bullet which are attached with the refineries, it is a caustic embrittlement which is a major issue, and wet H2S, because sometimes the H2S is also there in the process when we are producing LPG. That wet H2S is a major source because it generates ionic hydrogen, which creates which gives to cracking of the steel. So there it is very important. The post-weld heat treatment is very important to control the hardness factor. HIC or blistering damage develops without applied the residual stresses, hence post-weld treatment will not prevent the such damage. So what we have done is, in this case, we have provided an internal coating in the bottom side. So by providing internal coating, we are avoiding, in case of any wet H2S is coming and any liquid is coming, that will not be directly in contact with the steel. And second thing is, the hardness has to be monitored periodically in every M&I, and we have to ensure that it should be around 200 BHN. Then inspection and testing means, visual inspection we have to carry out in totally from the all internal surface, from the bottom, side as well as top. That is for the visual inspection for any weld defects. Visual weld defects are there. Ultrasonic gauging we have to do for any uniform thickness. And UT scanning we have to do for all the weld joints to ensure no cracking phenomena has taken place, and as well as some surface DPs are there like WFMPI or fluorescent magnetic particle testing. Those things has to be carried out. And maintenance, as whatever all the associated equipments are there like ROVs, those has to be checked, because ROV is a very important attachment with the safety of this mounted bullet. Working of ROV has to be ensured, so periodically this has to be checked. All PSV has to be tested every once in a year. It has to be tested. To carry out the testing of PSV once in a year, we have to have a spare PSV so that we can test it offline and then replace it. Overhauling and resetting of relief valves, and inspection and repair of all the concerned hydrocarbon utility lines, fire water, especially the sprinkler systems. Those things normally gets corroded over a period of time. and it gets neglected. Those has to be seen thoroughly, and it has to be tested during each and every M&I. Thank you, sir.
Thank you, Mr. Vadva, for your brief on mounted vessels, their maintenance and inspection. And maintenance and inspection of mounted vessel is of paramount importance. For the benefit of the House, I would like to inform that the revised SMPV rules have already been sent to the Ministry for notification, and a special chapter on manufacture, maintenance and inspection of the mounted vessels have been incorporated, and this has been in line with the other OISD standards. So whatever gray areas were there in the rule, that has been plugged, and I'm sure this will go a long way in enhancing safety. Moving ahead with our presentation, the next topic that we have is safety aspects in LNG storage and regasification, including FSRU. We have an international expert with us who has a degree in chemical engineering, Polytechnic of South Bank, and MBA from Henley Management College. David started his career with Flaw Limited in 1979 and has worked with more than a dozen organizations. He's currently with H Energy as Chief Technical Officer, and in his 35 years of experience, he has worked with companies related to oil and gas production downstream processing facilities. I'm sure we'll be enlightened by his talk. And may I request Mr. David Mariette to take over, please. David.
Thank you very much for that introduction, and thank you very much for inviting me to speak to you. I'm going to get straight into it. Time always seems to be of the essence, so if I can get... I'm a process engineer by background and spent many years designing process facilities. As I became more experienced and led larger and larger process teams, I tried to impress on my younger colleagues that you have to have a sound understanding of the physical and chemical properties of the materials to be handled. Without this understanding, it's impossible to effectively design any process facility, even more so a safe processing facility. With that in mind, perhaps I'll talk a little bit about LNG. Some of you here might be familiar with LNG. I believe you'll become more and more familiar with it over the next few years as LNG becomes a major international source of natural gas for India. LNG is natural gas, 80+% methane with C2, C3, C4 and nitrogen. I'll make some comments about the fact that it doesn't contain carbon dioxide or hydrogen sulfide or water later on. When the natural gas stream is cooled to minus 161 centigrade or lower, it becomes liquid, hence the term liquefied natural gas. At this temperature, the natural gas volume is reduced by a factor of 600 to 1. It is this volume reduction that makes intercontinental transportation by ships possible. And if you've been to some of the ports like Hazira or Darbol, you will have seen the Moss tank ships with their very impressive dome-like structures. That's an LNG carrier. Let's talk about the general properties of LNG, because understanding the properties of LNG are fundamental for a safe design. It's colourless, it's odourless, it's a dense liquid less dense than water, it's non-toxic, non-corrosive. I make the point, it doesn't contain carbon dioxide, it doesn't contain hydrogen sulfide, it doesn't contain water. It is a pure fuel. LNG spills will not harm the environment. LNG, if left to vaporize, it just sits there. It just sits there, boils off, it becomes natural gas. The issue becomes a little bit more problematic when the concentration of that natural gas becomes between 5 and 15% in air. It will ignite. and in confined spaces it will explode. LNG causes materials to become brittle and can lead to structural failure. Cold burns to the skin. Cold vapours can cause respiratory problems. Cold vapours are, when they're less than minus 110 degrees centigrade, heavier than air. They will sink into low spaces. It's point 4 to 6 that drive many of the principles in the safe design of all LNG facilities. We're talking about regasification. Regasification terminals are becoming familiar along the coast of India, especially on the west coast, up the north, Hazira, Dahej, Dabhol. They're actually very simple processes. You have a jetty with loading arms. The ship arrives and it pumps the LNG through the loading arms into a storage tank. The natural gas vapour in the tank is then pushed back into the ship. It's a pressure balancing device. When you want to use the LNG, you pump it out, and then you add heat. The LNG now is turned to natural gas. The clever bit actually is that instead of now compressing the gas, before you heat it, you have compressed it to the pressure you wish to export. So perhaps if you're up at Dabhol or down at Jagar, where we're developing a project, it's 90 bars. One of the problems with LNG is it's cold, therefore there's a tendency for heat leakage in. The LNG tanks are designed to cope with that, and the vapour which boils off the LNG is compressed and pumped into the liquid as it's been pressurised before export. It's a little bit like a cappuccino machine. If any of you like cappuccino, it's cool, you put steam in, and when the steam starts coming out, you know your cappuccino is warm. Let's move on. However, everywhere you have pressure and LNG, you have potentials for leaks, and they are a fundamental problem. But before we move on, the introduction talks a little bit about onshore facilities and the new, let's call it, breed of storage facilities, the FSRU. The picture top left is a terminal in Thailand, typical jetty storage facilities, pumps. The picture on the right is an LNG carrier offloading to an LNG FSRU. The FSRU has all the attributes of the onshore facilities, but they are located in the hull. In the FSRU there, you can see a large water outfall. This FSRU is using seawater to vaporise the LNG. Let's talk a bit about design. As a process engineer, one of the things I learned very, very quickly, if you want to have the maximum input and impact on your design and you want to make it safe, you want to make it simple, it's during your concept selection, matching your concept to your circumstances. As you move through the development process, you can continue to reduce your risk, but your opportunities for inherent risk reduction become less, and you're more into safety critical items, shutdown systems. As your design moves into fabrication and construction, and then into operation, you are into procedures. The best design is the one which has most inherent safety, as few safety critical items you need, and simple procedures. However, when we design facilities, and I have to stress, the design of an LNG facility is not unique to our business. Our previous speaker was talking about LPG facilities. Many of the things that I'm talking about here, he and his colleagues will have also looked at. However, the layers of protection are there. Primary containment. That's designed to make sure we maximise opportunities for keeping the LNG within the containment. It's about the design of the tanks, the vessels, the piping, material selection. Secondary containment. If leaks occur, and they do, can we contain the LNG or the subsequent natural gas within the facility boundary? Now, quite a bit has been mentioned in earlier discussions about how the general public has a tendency to encroach on our processing facilities. The sad thing is that is natural. We've seen it quite a lot in Western Europe, in North America, Canada, Australia. People have a tendency to move towards work. So keep the problem inside the boundary fence as much as possible. Safeguarding systems. If we have a problem, minimise the frequencies of the problem. Plant layout, again, how do we separate things? How do we stop a small problem escalating? Finally, the people, the operations people. One, well thought out operating procedures. Operating procedures where the operators have been fundamentally involved in their development. Training, understanding how the problems arise, how they are solved by the operators, how they are solved by the design. Training, regular training, not once every 5 years, but revisiting the training. I can't stress that enough. The more the operators are better trained, the better they cope with a problem. I've deliberately not laboured on standards and procedures. The principal standards standards for the design of LNG facilities are EN 1473 and NFPA 57A. I'm sorry, I hesitate a little bit. I'm more familiar with EN 1473. The interesting thing about EN 1473, it talks at length about various aspects of the design. However, it's got a very interesting comment, and the summation of that is it's not just this standard. This standard is part of a series of standards which are supported by a quality management system. If you want to be safe and you want to implement these procedures, you have to have an appropriate safety management system. It's not just the design, it's everything. So, I'll go quicker. Just to give you a quick insight, the top picture is what happens if you come in contact with LNG. You're burnt. Those fingers never recover. The bottom right-hand picture shows brittle failure of an LNG vessel. The loading arms. The most problematic area is where it connects to the ship. The loading arm base might be stationary, the ship can be going up and down. So we have powered emergency release couplings. I'd like to show you a video, it will take too long, but literally they part, you get a short outflow of LNG and they close. Picture top right is LNG being released from an LNG carrier. Bottom left is showing a dispersion modelling. Dispersion modelling is one of the tools in design. This is an example of a full containment tank. It's a tank within a tank, a nickel steel tank. Its inherent safety design is all the nozzles are on the top. Therefore, the only thing which comes out of the vessel is what you pump out of it off the top and the vapour. carry on. More dispersion modelling. We talked about the gap between buildings and things like that. Once you've got the release, work out, have you spaced the vessels far enough apart. Standard notation, which one used to have when I started, well, X meters between buildings is no longer appropriate. Bottom, this is what happens when LNG ignites in a steel structure. The design of facility is a practical point here. Because of the temperatures, large thermal expansion and contraction. Right-hand figure shows expansion loops on an LNG terminal. Vessel pumps. Pumps are in the tank, minimised. They're designed so you can extract them when the tank is fully in operation. You just drive nitrogen into the can. The trip valve at the bottom seals. You can pull the tank out. Top bonnet valve valves. No flanges. As the pipe expands and contracts, there's no exertion on a flange. Insulation. You've got a delta T across the insulation of 200 centigrade. The insulation is quite often as thick as the diameter of the pipe. FSRU, I will say very quickly, and time is now short. The principles of an FSRU embody all of those of an LNG carrier with all the vaporization systems of an onshore facility. LNG has actually quite a unique safety record. In its 70 years, only five major incidents. The fleet has grown from 100 vessels in 1995 to over 400. The number of shipping incidents have been few. No vessels lost, no lives lost. Biggest risk now, which was touched on earlier, is road tankers. 2 major incidents are recorded. LNG statistics are readily accessible on the internet. So, very quickly, you need to have, in developing the design, a sound understanding of the fluids involved. The LNG process, regasification process onshore is essentially the same. Sound understanding of the process, again, develop a safe design is important. Safe design starts at the very beginning of the project. Design standards must be complied with consideration to quality. If they're not, they won't be effectively implemented. Bringing all the safety issues together presents many design challenges, but they are not unique in the hydrocarbon industry. The LNG FSU challenges are the same as the onshore, but the impact of reduced space does increase the safety design challenge. And finally, the biggest risk the industry faces, and this is my view, is the increased transportation of LNG by road tanker. It's with these thoughts in mind, H Energy will give every possible support to organisations such as CCOE, PESO, OSD to ensure Indian LNG facilities are safe facilities. Thank you.
Thank you, Mr. David Mariette, for your lucid presentation. I do agree that LNG has an impeccable safety record. Probably the last accident was in 2004 in Algeria. And in fact, in 1944, the Ohio incident has enhanced the safety in the LNG industry. Again, coming back to the SLPV rules, the revised rules which we have sent to the ministry, we have a separate chapter which covers LNG extensively. I think this will go a long way in enhancing safety in handling and storage of LPG. Thanks a lot, Mr. David Mariette, for your presentation. Moving ahead, we come to our next presentation on automation. And automation is very essential for the hydrocarbon industry. To discuss this issue in details, we have an expert in Mr. Pradeep Yadav, who is the Executive Director, Automation, IOCL, Mumbai. He is an electrical engineer from REC Kurukshetra. Currently, he's working as ED Automation IOC. He's worked across various divisions of IOCL at various locations. He's commissioned and stabilized automation at a number of petroleum operating locations, including grassroots terminals. He's finalized the functional design specification of automated smart locations where entire operation is controlled through a control room without human intervention in the field. May I request Mr. Pradeep Yadav, please.
Good afternoon, respected delegates and organizers. Indian Oil is the biggest commercial organization of the country. It has around more than almost 50% of the market share. And it is continuing, the growth in petroleum products is continuing at a rate of almost 7 to 8%, not to talk of in double digit in case of MS. We have around 129 locations spread across the country, and to meet the increasing market demands, efficiency, productivity along with safety is of paramount importance. Peter Drucker in famously said, the aim of marketing is to know and understand the customer so well that the product and services sets in and sells automatically. This has been at the core of IOC since inception, but IOC took big strides in this direction by commissioning its first automated terminal in 1995. And it has been progressing regularly since then. Before automation actually took in, all operations including filling of tank trucks was being undertaken manually through deep rods. All associated facilities like pump house, taking out density, storage tank, dipping, invoice generation, recording of density, etc. were all manual. However, with the coming up of automation, all these facilities have been automated, whereby the interaction between the terminal officers, people visiting the terminal officers have greatly reduced, thereby leading to not only customer satisfaction, but enhancing efficiency overall and the safety culture of the location. Now, how actually the terminal automation works? The working of the terminal can be divided into three parts. One is operational process, other is accounting process, and then third is safety process. In operational process, it starts with indenting. There is a process which has been developed whereby a customer or a dealer can place indents through SMS. No sooner he gives from a registered his requirement, it is sensed by our system, and if the funds are available with us, it gets registered with us. Then the second step comes is availability of tank trucks. The tank truck, once it takes the load, it has to be acknowledged that it has delivered the load at that location. Once the facility exists as on date, whereby customer or a dealer can acknowledge the previous load through SMS, which is registered with the company. No sooner it gets registered, it gets acknowledged in our system that load has been delivered. Then the TT comes back and it is tracked through VTS. Every truck is fitted with vehicle tracking systems, and when it enters our zoning area, the TT gets registered with our system in the control room and automation system that gets transferred to our operating system. When the trucks are further to ensure the physical presence of the TT is ready to take the load, it is fitted either with RFID tag or they have been issued a permanent proximity card. There are two provisions which are existing as on date. Either TT is further acknowledged through RFID or by presenting proximity card that is available with him at the proximity card sensors, which are installed either at the main gate or in the TT parking area. Once this is done, the TT gets transferred to the TTQ. Now the question of selection of indent and a TT. In case of dealers, it carries its own load, and thus there is no provision of selection of a TT. It automatically gets allocated to the lot no sooner it comes to the terminal, and whenever bay is free. In case of transporters, the load is allocated to each of the tank truck by the system itself. There is no human intervention. It depends upon the previous load it had carried, kilometers it had traveled, and its time of reporting. So all activities are taken care of by the system, which brings in complete transparency, as well as the interaction part and people visiting the terminal and coming to the terminal to have their turn, that is eliminated. That means indirectly we are not only enhancing the efficiency and transparency, we are enhancing the safety culture at the location. Once this is done, and whenever the bay is empty and TT gets allocated to the bay, there is a filling advice note which is automatically printed at the security gate, and at the same time announcement is made that TT can approach the gate for being filled. No sooner it comes to the terminal gate, that fan slip advice is given to the driver by the security, who checks the fittings, safety fittings of the TT and allows TT to move in. At the licensed area, the card sensors are provided, where TT when approaches, it is unlocked. TT normally always comes in a locked condition. It is unlocked at that gate, and the card is presented to the card sensor for allowing TT to go in. If the card is authorized, then only the gate opens, and no sooner TT goes in, the gate closes, and this all action is through infrared sensors provided at the security gate. Once the TT goes inside, it has to go to pre-authorized bay. If it goes to any other bay, system doesn't allow its filling, and TT is asked to proceed to the authorized bay to load the authorized product. When it goes to the authorized bay, only authorized product can be loaded in that tank truck. And it starts with compartment number 1. Even to ensure safety there, provision has been made whereby a crew has to place fire extinguisher, has to cut off main switch, and to put wooden blocks in front of tires, and that has to be acknowledged by the driver at the automation system to ensure that these things have been complied. On presentation of card to the card reader at the loading bay, the truck number is displayed. Once this is acknowledged by the crew, the capacity and the product of the compartment number 1 is displayed. At the same time, to see that all safety features are there and they are complying to SOPs, they have to attach earthing clip with the TT, which is integrated with the system. Once the circuit is complete, on acknowledgement of quantity and the product, and insertion of the fill pipe inside the first compartment, once it presses for product to start, the product delivery starts. And to ensure that splash loading doesn't take place, the initial flow rate is at the speed of 1 meter per second, and once the loading arm gets submerged in the product, it increases to 6 meters per second, and for last 300 to 500 liters, depending upon the system configuration, it again comes down to 1 meter per second. This ensures that all safety features are automatically ensured by the system rather than manual, where you have to control and maybe you may not be able to control, and leads to splash loading and may lead to static charge generation, which may get dissipated, may not get dissipated, which depends upon the earthing. But in this, the system automatically ensures that all these features are taken care of by the system. This system gets repeated for compartment number 2, compartment number 3, or compartment number 4, whatever the number of compartments that a TT has. And a next TT or a bay becomes available for next TT only when the loading process of the earlier TT has been completed. Once the loading has been completed, he has to remove the earthing, and system automatically conveys to our operating system for TT to have been loaded and loading having been completed. It automatically generates the invoice which is available, which is printed at the exit of the licensed area. We have provided rooms there and with the printer, so that a conductor or a driver or crew doesn't have to travel to any other place. No sooner TT comes to the exit barrier gate, the invoice is given to him and he moves out. Only interaction of the driver is at the entry of the terminal or for locking before invoice has been handed over to him. This ensures that minimum time is available for the TT to remain inside the terminal. We used to take almost an hour or so for its turnaround time, which has further been reduced to less than even half an hour. We have both kinds of location as of now, where we have top loading as well as bottom loading. As of now, the flow rate is say 1200 LPM for top loading, which goes to 2400 LPM in case of bottom loading. However, there is a provision where we are going in for even for top loading and 2400 LPM even for top loading, which will further reduce our time, increase our efficiency, at the same time increase our safety features. The lesser the time the TT remains in the terminal, the more safe it is. And the people coming to the terminal number will remain same, but at any point of time their presence inside the terminal will get reduced. Then we have once the TT moves out of the licensed area by presenting a card to card reader, whereby gate opens and allows TT to move out. It gives a gate pass to the security at the main gate, and the TT moves out, where further it is tracked for its route, authorized route through vehicle tracking system. And the system gets repeated for the next cycle. And this way it continues without human intervention, and everything is tracked, everything is available on our records. Then we have accounting systems coming in. All pipeline transfers to OMCs or to our terminal or to our storage tanks is through mass flow meters. These mass flow meters are integrated to our system, and all accounting is based on those MFM quantities delivered. At the same time, all transactions during the day are picked up by the system at any time that a control room officer authorizes, and it compares with the quantity drawn from the storage tanks. All storage tanks are fitted with radar gauges, temperature sensors, density sensors, and all this gets correlated. Ultimately, at the end of the day, we are able to find out how much we have transacted and what has been the loss or gain at the end of the day. All these figures are from the tanks are captured by tank form management system, which gets transferred to SAP, and we are able to generate gauge books, record, etc. automatically through the system without human intervention. Even these records are available for generation reports on daily basis, weekly basis, fortnightly basis, and yearly basis, half yearly basis, whatever way we want, these reports are available. Means we are almost reducing human intervention to the bare minimum. It doesn't mean the strength is going down, but we utilize them for more creative works, and the process continues. Then we come to safety features. When we are automating our facilities, we are eliminating human intervention, most of the activities are undertaken by the system itself. The safety features have to also to be automatic. In addition to the movable safety equipments and fire extinguisher that conventionally we used to have, there is a centralized hydrant system provided across the terminal. Not less than 30% of our capital cost goes towards firefighting features being provided. This hydrant system maintains a minimum pressure of 7 kg, which is maintained through water storage tanks, through fire engines, and so that at every point of time the pressure doesn't go below 7 kg. Whenever we are operating a hydrant point or any sprinkler system, when the pressure goes below 7 kg, the system tries to bring it back to 7 kg pressure, and if it doesn't, then the first main fire engine starts. If still it is unable to maintain that pressure, the second engine starts, and depending upon the sequence, it continues. To ensure that we are able to control fire with the minimum manpower, all the walls at the terminal are fixed with actuators. All these walls can be operated from the control room, and there is no need for a person to actually visit the site. Our terminals, automated terminals, are provided with centralized foam pourer system, and foam pourers as per OSD requirements have been provided on fixed tanks. In case of floating roof tanks, automatic fire suppression systems have been provided. It is able to operate not only sprinkler system but also the foam system sitting in control room, whereby all walls, because all walls are automated, so one is able to monitor and operate these walls from control room if it is not possible to reach the site. That's why if a location becomes vulnerable, it may be possible to control all fires from the control room. To have actual control on this, all locations are provided with CCTV cameras where all activities are monitored and all security features are being placed, are kept into consideration. This was the feature that we used to have, whereby there used to be people all around, and we had to take care of not only the safety of our equipments at the terminal, but also the people who are coming to the terminal. But this automation has brought a revolutionary change, whereby the strength coming to the terminal has come down, and we want in all our future terminals, we want them to operate as ATMs. With automation setting in a big way, thrust is towards maintaining not only operational equipments but safety equipments, and thus to obviate incidents of near miss, not to talk of accident, which earlier speakers have been speaking since morning. This will make operational comparable to air safety that was talked of in the morning. Like air traffic control, we will have oil terminal controls as well. Today we are controlling only the terminal sitting from a control room, but future is not far off when all our terminals will be controlled from a centralized control room sitting at what place in the country. To give you glimpses of some of the features that we have in automated terminals is this. This is for bottom loading, earlier was for top loading. They want the latest feature of bottom loading. This is a pump house manifold. Again, pump house manifold. These are water storage tanks along with fire hydrant system. This is the control room that we have, whereby all people sitting only in control room are able to control all activities. And this hydrocarbon detector system, HVLRs. This is RSV and DBB that we have come. You have heard of Jaipur incident, you have heard of whereby something happened because of hammer blinds. Those have been replaced by better walls. There is a rim seal fire protection that I talked of. And thank you.
Thank you, Mr. Yadav, for your effort on automation and Indian Oil Corporation's effort on automation. This will definitely help in enhancing safety and reducing the human intervention. In fact, Bharat Petroleum also have a project called Nano, no automation, no operation. So it's a good indication that the industry is moving ahead in the right direction, and to ensure that there is as little human intervention as possible and enhance safety. Moving ahead, we have a very interesting topic. It's on storage of LPG and crude oil cavern. And for discussing this issue, we have an expert in the true sense. He is a mechanical engineer from Banaras Hindu University and has masters in energy planning and policy from the Asian Institute of Technology, Bangkok. And currently he is the CEO and MD of ISPRL. He has been involved in the first underground cavern storage project and largest storage in the facility. He was specially picked up by Ministry of Petroleum and Natural Gas to head ISPRL because of his rich experience in underground rock cavern storage facilities. He is responsible for execution of the strategic petroleum reserve projects, and 3 projects put together can store approximately 41 million barrels of crude oil. He has also introduced reverse auction techniques for item rate contracts and is leader of OISD team for development of OISD 230 standards. He is none other than Mr. Rajan K. Pillai. May I request Mr. Pillai to please enlighten the gathering on cavern. Mr. Pillai, please.
Mr. Sen, thank you for the introduction. Other speakers on the dais and friends. My topic for the day is safety challenges in construction and maintenance of for LPG and crude oil caverns. But at the moment, the real challenge for me is how to make it a lecture of only 10 minutes. And fortunately, I have about 23 slides where I don't have to talk much, where the graphics, and 5 are only on topics. 10 have matters. So I think with that, I'll just run through. This is how I have structured my presentation. First, I will just briefly talk about the underground storages, and then talk about the risks and hazards in underground caverns. Later on, I'll talk about the mitigation methods. So just briefly, of course, this is stretched a little. This is the hydraulic containment principle for rock caverns. So basically, we are creating a cavity underground and using the water pressure to store the product within the cavity. And depending on the depth that you go to, you can store any liquid. You can even store LPG, like we have done in our very first project for cavern in the country. This is the very first project in the country, cavern project I'm talking of. It's the SLPG cavern project. It was a joint venture of HPCL and Total, and the entire cavern was excavated through vertical shafts. One shaft is approximately 6.5 meters in diameter. The other one, which is the operation shaft, is about 4 meters in diameter. The 4-meter diameter shaft goes down to a depth of almost 201 meters below mean sea level. And all the equipment had to be taken down through these vertical shafts for excavation of these huge caverns. Now, this is just a photograph of how the equipment was taken. If you see, these are huge excavators going down through one of the vertical shafts. And this is the isometric of the ISPRL facility, which is at Visakhapatnam. We have 3 such facilities. ISPRL is a very small organization, and you'll be surprised that at the moment, we are 5 of us here, and we are 35% of the total strength in ISPRL. And my four of my colleagues were here have done a wonderful job in creating these facilities. In the Vizag facility, we store about 1.3 million metric tons of crude oil. This is already full. At the Mangalore facility, we will be storing about 1.5 million metric tons. This is also ready. The Padur facility is ready, except that the pipeline leading to this is not finished. About 12 kilometers out of the 36 kilometers is yet to be finished, and we hope to finish it in the next few months. There's a power line also which has to be finished, but hopefully we should be able to commission this facility in this year. This is for something like 2.5 million metric tons. Now, this is a typical cross-section of the storage. I'm just giving you these photographs so that you have an idea of what the cavern is. There's a huge amount of work that was done. Almost 30 kilometers of tunneling was done. Boreholes to the extent of about 76 kilometers were drilled. We have excavated almost 21.6 million tons of rock. Now, when we are talking of such huge quantities, there are a lot of risks, obviously. And I'll just give you an idea of the type of risks that are there in underground works. Now, imagine there is a crack that is propagating from the roof of the cavern to the top, and it is in the form of a wedge. Now, this could be very dangerous. You know what can happen. Now, it can happen even on the sides. If there are cracks on the side, it can cave in, and it can lead to disaster. We had one incident at Visakhapatnam because of this. There was a huge amount of rock that came crashing down, and we had one fatality. The other risk is water ingress. Let us say there's an aquifer and we cut across the aquifer. There could be a huge ingress of water, and that could be dangerous. You can see this photograph, how the water jets out from the cracks. This is a photograph taken from the SALPG project. This is there's a risk of transportation because huge amount of equipment is used in these projects. We use drill and blast techniques. This is just an animation of how we blast the rock. We charge it, drill holes, charge it, and boom. That's what we do. And this whole quantity is then taken out. There's a huge amount of explosives that we need to handle. 8,400 tons is what we have handled in ISPRL. There's this issue of vibration, which is another major concern. I'm not going through the whole thing. This material is there in the booklet that has been prepared by PESO. Fumes and dust is another issue in underground works. There are also the risks during the operation phase that we need to address when we are designing caverns. Now, let me straight away come to the mitigation measures. I spoke about a wedge failure, rock coming down. What we do is we drill holes into the rock, then use shotcrete as well as rock bolts to stabilize the whole structure. So you can see radially there are rock bolts, and then we coat the walls with shotcrete. Now this stabilizes the structure. Also there is this possibility of movement of the walls, and we put optical targets on the wall and keep measuring the amount of movement that is there on the walls. Now in case the movement is large, then we need to add more rock bolts and shotcrete. The issue of water ingress, before the water comes in, we need to address it. So we drill holes into the cavern or in the walls of the cavern, test whether there is any seepage. If there is seepage, then we pump grout through the holes and seal the rock. That's what we do. So this is, and in case we don't do it, it can be very dangerous in underground works. Traffic hazards, this I will not talk about too much, but then let me explain that when you have a huge amount of machinery working underground within a constrained space, one has to be very careful in managing the movement of these trucks. You know what a truck can do. Recently what happened in Paris, of course, that was somebody who rammed into people, but an uncontrolled truck along a ramp which is at an incline can be very dangerous for people. Handling of explosives is something very, very important. Just covered it briefly here. Excessive vibrations. Now, in underground works, we use huge amount of explosives, like I mentioned. But then there is something called a smooth blasting technique that we adopt. Now, in the smooth blasting technique, what happens is the way the blast progresses is taken care of by delay in the explosions, and from the center the material starts exploding, and once it reaches the edge, it's only a peeling action that takes place. So you have a peeling action around the wall whereby the wall does not get damaged and the amount of vibration that is induced is less. So this is also important, because if these caverns are close to residential areas, you could have problems. We had a problem like this in Visakhapatnam. Our cavern is not very far from the naval colony, and there were complaints from the naval authorities. We addressed that and we could manage without major problems. The fumes and dust is another major issue, like I mentioned. So we use huge blowers, blow a lot of air in, make sure that the oxygen levels are close to 20%, so that the people do not have any problems. I'm talking of the workers. We make sure that the monitoring of the oxygen is done close to the faces where people have to work. And this is something that we need to address for the operating phase. Let us say the water table drops. Now this I'll explain a little more, so I'll just take a few seconds to explain this. This is important because if, let us say, the water table drops, then the containment principle of a cavern is affected and you could have the product leaking out. Now we cannot afford such a thing, so we monitor the water table, the entire water table close to the cavern, and we're talking of within 500 meters radius of the cavern, we monitor the water table. So we drill vertical boreholes, we have piezometers there to see the level of water. In case there's a drop, then we need to pump a lot of water into the water curtains which are above the cavern and ensure that the rock remains saturated. This is the last of my slide. This is for LPG. Imagine there's a guillotine failure on the top and LPG from the cavern can leak out. Here what we do is just let water flow into the sump, into the bottom. Then there it goes into a well. The well ensures that no LPG then climbs up through the pipe, as you have shown. I'll just repeat this animation. We look at this animation. First is I've shown the pipe separating out, that's a guillotine failure. Water goes in, fills the bottom sump, then the water goes into that well and rises up. Because of the height of water, the column of water, there is no way LPG can find its way out now. The cavern is completely sealed. And this is what we have done in the SALPG project. So even if there's a major failure of pipeline on the top, we just have to pour water, let water flow into the cavern, and it can be completely sealed. Now here I've shown, in case there are different products stored, how to ensure that there is no movement of this product from one compartment or one cavern to the other. We just have vertical water curtain tunnels which will ensure that. We also inertize the caverns to ensure that no oxygen is there, or at least it is to the extent of less than 5% when we put in crude into the cavern. And before I end, just let me give you an idea of the wonderful work that ISPRL and SALPG have done. We have set some national records, and we have also wonderful safety records. At Mangalore, we achieved 5.6 million accident-free man hours, which for underground works is very, very creditable. Thank you.
Thank you, Mr. Pillai, for your brilliant graphic presentation and for your effort in constructing the caverns. In fact, constructing the cavern has been a challenge for the regulators too. Incidentally, all the chief controllers who were associated during the period of the construction of caverns were present here today in the morning. Unfortunately, they're not here today. But it's been a big assistance and a challenge for PESO to accommodate the industry for constructing this cavern. But we still have a long, long way to go. We are far behind other countries in terms of caverns and storages. We probably need to have more storages, but all the same, the effort made by ISPR needs to be applauded. A big round of applause for Mr. Pillai, please. Coming to the last topic of our session, mechanical design consideration and ND techniques for pressure vessels. The need of the hour and need of the nation is green technology. Now we have with us an eminent expert in Mr. Tom Holthius, who is a graduate in mechanical engineering with specialization in production technology in Netherlands. He joined in Seed Business School in Fontainebleau in 2000. He joined Hooklu Industrial Gases in 1980 and worked in various fields of research and logistic, project management, quality assurance. He is currently with Lloyd's Register. During his career, Ton has built up ample practical experience with strategic decision-making at company level and became specialized in the management and continuous improvement of change processes within organization. May I request Mr. Ton Althius to come to the dais, please.
Thank you, Chairman, for the nice introduction, and good afternoon, ladies and gentlemen. Introduction was necessary. I'm the new kid on the block, I would say. I'm 2 months in India and leading Lloyd's Register inspection services in India. We heard today a lot about safety, and my presentation is a bit back to the basics, back where it starts: components, pressure equipment, and design. So I would like to use the time today, the 10 minutes, to go into that topic for today. And there's an enormous nice sentence, mechanical design considerations. In fact, it is about how can we mitigate risk by design. We have built a lot of knowledge over the years, and we are bringing this back into design. That's what we will discuss now. But first of all, I said a new kid on the block. I don't know if you know Lloyd's Register, but we are I would say a not straightforward company, and give me 1 minute to tell you who we are. The owner of our organization is a foundation. We are a charity concerned with safety and life and promoting education and research. We are independent from shareholders and governmental control. The money we make is reinvested in the society, universities, projects, and we are funding science, engineering, and technology research and fund education. And technical excellence is also where we look at project. I said that we have several projects. What we do nowadays is drone inspection. We are looking at rules for drone inspection. We are looking for rules for additive manufacturing, 3D printing, risk-based inspection. A lot of technologies and techniques we are developing together with the manufacturers, with you, in fact, to make our life safer. Today, I said already, it is back to the basics, pressure vessels safety and integrity. We will look into risk mitigation, and we will look into non-destructive examination, the advantages and reliability of flaw detection. It is all about, safety is all about the right design conditions, the right materials, the right processes, inspection and testing. Let's look into that more carefully. The regulations and codes we are using for pressure vessels, static and mobile, are designed and constructed to contain fluids in a manner that loss of containment doesn't occur. Leakage of fluid or any mechanical or structural failure of such equipment may lead to accidents on site and pose danger to life and property. National rules and regulations, we have that already, are framed to ensure safe operations of these vessels, and usually they stipulate the use of well-known national and international codes and standards. So how can we mitigate risk by design? Now, there are some supplemental conditions or thoughts I would like to guide you through. What we need to take into account when we design a vessel is the static head is to be considered together with the design pressure. Vapor pressure at maximum temperature should be used that a gas is likely to attain as design pressure in cases of insulated vessels. From the other side, the metal temperature should be used at boiling temperature of the liquefied gas at atmospheric pressure. When applicable, and for toxic and corrosive fluids, an adequate corrosion allowance should be considered to account for any corrosion. All additional superimposed loads, such as wind, seismic, applicable for the location of the equipment, shall be considered, and these become significant for large storage vessels. All filling and discharge openings for flammable, corrosive and toxic fluids shall be multiple closures to mitigate risk of leakage. We are not there yet, so I have some pages to go through with you before we have a safe piece of equipment. High toxic liquefied gases, there should be no bottom openings below the liquid level, something we heard already said by the previous, one of the previous speakers. 2 independent safety relief valves with each valve a full discharge capacity, and on the flange connection, and no threaded connections are allowed with regard to corrosion and stress corrosion cracking. Vessels for toxic, flammable and corrosive substances shall be post-weld heat treated to mitigate the risk of failure due to stresses and hotspots created by welding process. Full volumetric NDE shall be performed for toxic fluid service. Mounted bullets for storing LPG. Now, I repeat my previous speaker, you need to look at the settlement, seismic loads, soil pressure. There are a lot of impacts from outside you need to take into account. For spherical vessels, special attention should be given to supports and their attachments. Then a special item called stressed vessels. When you want to use austenitic steel and you want to, I'm mixing up with the next bullet point, but for our cryogenic storage tanks, non-corrosive, erosive service, we need to be sure that it has not an adverse effect on the austenitic steel. Multiple cell cylinders, which they are, when they are used, they need to have the same uniform nominal plate thickness. Utilization of cold stretching is not permitted for parts with primary bend stresses. Re-rating for registered maximum allowable work pressure is only allowed for cold stressed vessels when you do it for the whole. Particular attention must be paid to weld details and avoid the areas of stress, concentration and high restraints, so that when the vessel is cold stressed, all components are evenly stretched. Non-destructive volumetric examination of materials and weld joints have an important link with design philosophy in determining the assured level of integrity of such critical pressure equipment. Non-destructive examination plays a crucial role in flaw detection at times of construction, but also later at the service examinations. Traditionally, we have depended on radiographic techniques as flaw detection methods, mainly because it offers a permanent record of the exempt area. Now there are advanced ultrasonic methods available which are hazard-free, reliable, and produce a permanent record of exempt area, and that is time of flight diffraction, TOFD, and phased array ultrasonic testing, PO2T. An example of how it looks like in theory, you have on the left side the source, on the right side the receiver. You send out an ultrasonic noise and you get in fact 4 signals. You get your lateral wave signal, you get your black wall reflection signal, and you get 2 signals from the diffraction area. For the phased array ultrasonic test, it works in a different way. There are a lot of small ultrasonic transducers which are able to pulse independently, and you are creating in time a pulsing sequence in a long row. So there is a pattern of pulses, and you can result a beam into a set angle. And when you look into an example how that looks in practice, you see on the left the probe, you see in the plate metal three small holes, defects you can say. On the right you see what is coming out of the measurement. In this case it is a calibration, so you see nicely that there are some defects in the plate, luckily. There are some advantages and disadvantages, and I would like to share that with you. The advantage, it is a really fast method of examination compared with radiography. There are no radiation hazards, it's environmental friendly, you can continue with work close by, and it really works for higher thicknesses. There's excellent flaw detection, and especially TOFD is accurate for sizing planar effects. Real-time imaging. The storage of data is there, as I mentioned. Convenient and safe both for indoor and field application. No constraints in thickness. Acceptable nowadays for a lot of construction codes, ASME, European standards. There are also disadvantages, and they are lying in the fact that it is relatively expensive, the equipment, and also with regard to training, you need to make sure your operators are really well trained to use this. Then my last sheet, I would like to give you some information about this technology, and it is not our information, but I thought let's share that with you. There was a courtesy paper earlier in Durban in 2012, where they did a field study on the method in comparison with the more classical way of examination. And you see here that radiography, RT, in comparison with PO2T, is comparable or maybe a bit better on the smaller thicknesses. But when you move to higher thicknesses, the PAUT is doing better in every direction. So these are not our figures, but I would like to share it. But it is really a very compatible method of examination. Thank you.
Thank you, Mr. Ton Holthus, for your elaborate presentation on NDE techniques and the demonstration on POT and TOFD. In fact, in the European countries now, they've moved over to these techniques of examination, and they're doing away with radiography. We've come to the end of this session, and I must thank all the speakers for their excellent contribution during this session. A big round of applause for all the speakers, please.